Mr. Acianto, the time is yours.
Thanks a lot, Pak Arif, my favorite young lecturer. Let me first share my screen. Yep. Can everybody hear my voice and see the PPT clearly?
Yes, the voice is very clear. The PPT is also very clear. Thank you, Mr. Astianto.
Yep. Good afternoon, all the honorable presenters, participants, and also audiences. On this valuable moment, allow me to deliver our experimental research paper presentation entitled Time Series Differential Pressure Fluctuations of a Flooding Regime, a preliminary experimental research investigation on a 1 to 30 downset PWR hot leg geometry. I am Achilius Hermawan Astianto on behalf as the speaker of the authors. This presentation contains 4 main sections. So the introduction, some previous works, the methodology, data, and analysis. Several concluding remarks will also be delivered as the findings of this present work. So as an introduction, let us consider an accidental scenario in the primary circuit of a pressurized water reactor or PWR, namely loss of cooling accident or lockup. So as a result of a small break in the reactor primary circuit, there will be a suddenly pressure drop causing a phase change and results on a countercurrent flow along the hot leg, a part in the primary circuit which contain a horizontal elbow and an elbow and also a inclined parts, namely the riser. Once the steam flow rate increase, a limit of the countercurrent flow might be reached. It is called countercurrent flow limitation or CCFL. So the CCFL initiates a flooding regime in which the particular or total fluid flows currently with the gas along the hot leg. This phenomenon, of course, gives disadvantage for the emergency cooling process. So furthermore, it is very common to assess the pressure drops characteristics during CCFL research. The fluctuation of this particular parameter may indicate inception of the flow regime transition from a counter to a co-current flow. Hence, several statistics tools such as the probability density functions and also the power spectral density give opportunity to investigate the characteristic of a time series pressure fluctuations. So the research questions may be what like the differential pressure fluctuations during flooding regime are, and based on those statistical tools, do the fluctuations deliver certain meanings? This part of section describes several previous works on countercurrent flow limitation in hot leg parts. So this all in the hot leg parts, hot leg geometry. It contains such working parameters investigated, and they correspond to some results obtained. And we consider several of these parameters in our in the present works also. So the experimental apparatus scheme or the schematic is shown in the figure on the slide. The test section, the main test section were a complex geometry representing the convoy PWR hot leg in a 1 to 30 downset. The supporting components includes the RPV simulators and also the steam generator simulators. The other system contain also the water and the air supply systems, and also the measurement and also the data acquisition systems. The data tabulation were carried out as follows. So water from the bottom container was pumped into the upper container, and as a result of the gravitational force, the water later flowed along these parallel channels. And to manage the water flow rate, several water flow meters were installed and controlled by several valves. Then the water filled the SD simulator and flowed along the hot leg and go to the RPV simulators. On the other hand, meanwhile, I from a compressor in a constant pressure controlled by a pressure regulator through the flow meter, the airflow meter, and enter the RPV simulators, float along the hot leg countercurrently with the water, and enter the SG simulator and release to the atmosphere. On the other hand, the measurement systems used in the data tabulation consist of a differential pressure transducer to obtain the time series pressure differential voltage signals, fluctuation between the SG simulators and also the RPV simulator. And to obtain other information regarding the water level in the RPV simulator, we also assess a visual observation through a measuring line. And it's validated by a static pressure transducer. Both pressure transducer were connected to a 12-volt power supply and a data logger interconnected to an analog digital converter and also signal amplifier and a personal computer. So the slide shows the result obtained. The left picture shows that the onset of flooding or CCFL curve can be divided into 3 regions based on the relationship between the water and the air to the CCFL. The first region shows that the air flow rate that initiates the flooding decreases with the increase of the liquid flow rate. The second region gave an opposite trend. The air flow rate that initiates the flooding increases with the increase of the water flow rate. Furthermore, in the third region, the increase of water flow rate tends to fasten. This is CCFL again, almost similar with the first region, but it rather fluctuates. And in some comparisons, in agreement to those several previous works data, we do obtain also linear graph as proposed. We do not obtain also a linear graph that proposed by the Wally CCFL correlation. However, there is still agreement with those results regarding that certain trends. We obtain similar trends to Wong-Weiss, and also Badarudin and co-workers data in which the flooding curve were divided into 3 regions also based on the effect of the water flow rate on the CCFL. So in dimensionless liquid superficial velocity range or certain range, 0.07 to 0.2, there is an agreement with all previous data comparison. In this range, the air flow rate that initiates the flooding tends to decrease with the increase of the water flow rates. So in the next small range, 0.2 to 0.25, there is still similar trends to Wong-Weiss's data, even though it underpredicts the data. This is our data. This might
Excuse
be
me, Mr. Astainto. The time is almost over. You can make it faster, please.
So, the next slide is the pressure differential fluctuations between the SG simulator and the RPV simulators. So it can be seen from the graph that for a given liquid superficial velocity with several gas superficial velocity, the PDF obtains shows that there is a fluctuation trends on the main data. But for the standard deviation, there is a decrease trends. Furthermore, but when we continue to assess to certain other values representing its regions respectively, the graphs obtained do not show the uniform trends. The means and standard deviation comes with fluctuation trends. Meanwhile, when we observe the gas superficial velocity on the such dominant frequency, from the pictures, it can be inferred that the maximum spectrum decreases with the increase of the gas superficial velocity for a liquid superficial velocity given. But however, for several liquid superficial others velocities, the results look different. Even the trend still saw an increase in dominant frequencies with the increase of the gas superficial velocity. The maximum spectrum tend to decrease with the increase of the gas superficial velocity. So this is the other comparison that we make from, we want to see the effect of the liquid superficial velocity. Overall, the trend is a little bit different. And furthermore, for several other gas superficial velocities, the results look a little bit different. The trend still shows a fluctuation. Trends for both the dominant frequencies and the maximum spectrum with the increase of liquid superficial velocity. So the rest gas superficial velocity is taken from such region that we divided before. So according to the results above, the results we obtained above, we notify some concluding remarks as follows. Firstly, some agreements in the CCFL curves with the previous work's data imply an advisable research methodology on the present work. Secondly, the second region on the CCFL curve gives advantage on the LOCA scenario. And the third, the pressure drop tends to increase with the increase of the liquid superficial velocity during a flooding regime. So thank you for your attention, and allow me to return the time and the platform back to the honorable moderator. Please, Pak Arif.
Okay, thank you very much, Mr. Astianto. It is a very interesting preliminary research that revealed the pressure characteristic of CCFL. I think the result is very solid, and surely it will be a good basis to conduct the further research.